Hello, welcome to section 22, forced second order circuits. In this video we will be looking at how to find the particular response of a second order linear differential equation. So those are going to look something like this, where we're going to have a second order derivative right here, this guy, as our highest order. And we're going to try to model the response as Ke to the SPT, and then we can either use substitution to do it, or we can use integration if substitution is not possible. So our example problem. So let's get that up. Alright, so we're trying to find the particular response for dv dt squared, the second derivative of v plus 6 first derivative of v plus 8v equal to 12e to the negative 2t. So let's try substitution. Try setting all of our ddt's equal to sp. Sp is negative 2. You can see that by looking up here. It's already in the Ke to the SPT form. So we'll stick a negative 2 in there for all of those. So in that case, we'll get a negative 2 squared, v particular plus 6 times negative 2, v particular plus 8, v particular equal to our right-hand side, which is 12e to the negative 2t. So when we do the math on this, we will get 8 minus 12 plus 4, which is going to be equal to 0, v particular equal to 12e to the negative 2t. So this is our same thing that we saw with first order circuits. When I get a 0 over here, I can't divide by 0. So this is the indication that we cannot use substitution. And the reason for this is because one of our roots, either S1 or S2, or both, are equal to negative 2. So let's find those roots. So S is equal to negative 6 plus or minus the square root of 6 squared, which is 36, minus 4 times 8, which is 32, all over 2. So we get negative 6 plus or minus the square root of 4, because there's a 4 in there, which is 2 over 2. So we're going to get I believe a negative 4 and a negative 2 as our roots. And sure enough, right there is our problem. We have a negative 2 as one of our roots for our natural response, and our forced response has the same basically frequency. So they will not play nice together. So we're going to have to use integration for this. So integration looks similar to what you saw for first order, the difference being that we're going to do it twice. And we want to be strategic about which one we do first. So we don't want to do the one that matches first. We want to do the one that doesn't match first. It makes the integral a little bit easier. You can do it either way. So we're going to start with the negative 4 first. So we're going to get, instead of saying, normally we would say that v particular equal, we're going to say that g2 equals to e to the negative 4t, integral e to the 4t. So I'm using this 4 right here. And then we put the right-hand side in here. So our right-hand side is 12e to the negative 2t. And dt. So when I do that, so my 12 is going to come out. I'll have 12e to the negative 4t. And then I integrate e to the 4t. And I will get 4e to the 4t. When I integrate, I'll get not 4, 1/4. Let's make sure we do that correctly, which I haven't done here. So you have to combine those exponentials. So let's try that one more time. So e to the negative 4t, e to the 4t, 12e negative 2t. I'm going to pull the 12 out in front. It's a constant, e to the negative 4t. We have an integral, so we have an e to the 4t and an e to the negative 2t. When I put those together, I'm going to get an e to the 2t dt. I take that integral, I'll get 12e to the negative 4t, and then inside of here I will get a 1/2 e to the 2t. And then I will be able to clean this up. We will get 12 over 2 is 6, and then e to the negative 4t, and that we will get an e to the negative 2t. So that's our G2. So what we do with this is we then say v particular is equal to, we're going to use the other root this time. So this time we're going to use the pink one, and we previously used the non-matching one first. So just kind of some color coding to help you out there. So we're going to end up with e to the negative 2t integral e to the 2t. So this is all from this. Now we're going to put in our G2 here. This becomes 6e negative 2t dt. So again, I can bring the 6 over, 6e negative 2t, and then I'm going to integrate. And so e to the 2t minus that, this becomes an e to the 0. Oops, you can't see that. It becomes an e to the 0, which is just 1. So when I integrate this, I'm going to get 6e to the negative 2t times t for my integral. So it is 6t e to the negative 2t is v particular. Alright. So again, we would like to do substitution if possible. Substitution is pretty quick, but if you have a root SP that matches one of your natural response ones, you will get a case where you're going to get a 0 here, if either of these. So then you have to do integration. So G2 equals pick one, pick the one that doesn't match. It makes the integration easier. Put your right-hand side, your G1, in here. Then find v particular by integrating with the other one that you didn't use, so the one that does match last. Put your G2 in there. All right. Hopefully that helps. If you have any questions, feel free to reach out.